Welcome to AI Tutor. Our journey begins with understanding real numbers. Real numbers encompass both rational and irrational numbers. Rational numbers like 1, 2, or 3, 4 can be expressed as fractions, while irrational numbers such as 2 or pi have never-ending, non-repeating decimal expansions. Now, let's explore Euclid's division lemma, an instrumental theorem that provides in-depth understanding of the complex properties associated with real numbers. Before we delve further into the rich tapestry of mathematics, it becomes vital for us to comprehend the essence of what Euclid's division lemma embodies. A fundamental understanding of this lemma is paramount and will illuminate the intricate world of numbers for us. Let's take a moment here to understand the variables involved in this lemma. We've got a and b, which represent any two positive integers in the realm of numbers. Then we have q and r, unique integers that are the intriguing results of the equation formed. Their uniqueness is what makes this lemma so fascinating. Now, the study of this lemma is not complete without a detailed look at the conditions that apply to these variables. It's important to remember that these conditions are not arbitrary, rather they are the backbone of the lemma. They guide the equation and help us understand the interaction between these variables. The lemma suggests in its profundity that for any two positive integers a and b, there exist unique integers q and r that align with the equation a equals sine bq plus r. But that's not all. There is a very specific parameter within which r exists, 0 RRB. This restriction sets the equation in motion and ensures the uniqueness of q and r. Now let's ponder on a critical point of this lemma. The distinctness of q and r is not merely a mathematical phenomenon, it is the key to unlocking the lemma's true potential. It's essential to grasp the conditions that apply to these variables. Finally, we return to the proposition. The lemma suggests that for any two positive integers, a and b, there exist unique integers q and r such that a equals sine bq plus r, where 0 can be uniquely expressed as products of prime numbers. This theorem, fundamental in the field of mathematics, offers a clear and concise approach to understanding the intricate structure of numbers. By breaking numbers down into components, we reveal their true nature. It's a fascinating and vital aspect of number theory. To exemplify, the number 12 is represented as 2x3, where 2 and 3 are considered prime numbers. Now let's work through some examples to solidify our understanding. Let's start by understanding what prime factorization is. It's the process of determining the prime numbers that multiply together to make a certain number. Now let's look at our first example, which involves the number 36. It's a composite number, meaning it can be divided evenly by numbers other than 1 and itself. It's crucial to remember that prime numbers are the building blocks of all numbers. Now let's find the prime factorization of this composite number. By using the method of prime factorization, we can see that 36 equals to 2 times 2 times 3 times 3. This breaks down the number into its basic prime components. Solution: 36. Here are some important points to remember before we move on. 1. Real numbers include both rational and irrational numbers. These numbers form a significant part of mathematical calculations and concepts. 2. Moving on to another important concept, Euclid's division lemma. This is a key tool for dividing integers. It's a fundamental principle that helps understand number theory. It's an incredible theorem that impacts the way we deal with the division of numbers. 3. Lastly, the fundamental theorem of arithmetic, a cornerstone of number theory, establishes that every positive integer is characterized by a unique prime factorization. Now, it's time for you to apply what you've learned. Take a moment to pause the video and gear up to answer these tailor-made math problems. These problems are designed to reinforce your understanding, so take your time to ponder over them and work out the solutions. Remember, learning takes time and patience, so don't rush. Once you're done, let's move forward. Just hit play. That's it for this chapter. We've navigated through some fascinating concepts, haven't we? A quick summary to make sure we've grasped them. Our next adventure awaits in the upcoming video, where we'll dive into Name the Next Chapter. A sneak peek for you to tantalize your curiosity for the forthcoming knowledge expedition. Appreciate your time and attention in watching. If this served you well, reciprocate with a like, share, or subscribe. Let's continue this journey of math enlightenment together. More intriguing insights on their way to you. Stay tuned.